Well, my dear, today we can understand about that operational amplifier. It is a IC, integrated circuit. How it is work and inside of the operational amplifier, what happened? These things I want to understand. So first of all, I want to say one very important things that is. Uh, First of all, I want to say that I have in the previous two module we have discussed the introduced the IC, introduced about the operational amplifier, and after that I am disclosed about the IC, that is IC 741. And about the IC 741 there is some gradations, com grade, in grade, mil grade. These things I have developed, I have already explained. And also I have also explained about the 741, what is the reason behind this 741 and all those things. Now today we just for the purpose of the 741 and just start inside of the 741 what is the operational amplifier. Now as per the AOTD AP rules at the first rule of my channel, that things we know that operational amplifier is the operational amplifier. It can operate and then amplify. These two things are there in the operational amplifier. So next we go for the diagram of the operational amplifier, and which is very very important. You show the operational amplifier is looks like that. This is the output, this is input, this is also input, this is the inverting input, and this is the non inverting input. This plus is non inverting input, this is minus, this is the inverting input, and there is a output. Okay, in case of operational amplifier it is looks like that. This is the diagram, and it can work from this side, which is the input, and this is the output side. And you show there is two input, that is the non-inverting input, that is the plus, and there is inverting input, that is the minus. Okay, so all of you know about these things. I want to say one very important things of the non-inverting and inverting terminal concept. Non-inverting and inverting terminal concept, that is if you introduced one signal in here, if you introduce one signal in here, so what happened, as the operational amplifier, it is the output given the amplifications, which is looks like that. Suppose I am introducing one signal in here, this is representing here. Actually I want to understand about the operational amplifier at present. Now then we can go for deeply about the operational amplifier, then we can understand very fastly about the things. But things is that to understand about the non-inverting and inverting terminal, we want to understand this. To understand about non-inverting and inverting terminal, we representing these things like that way. So for that reason, this is the input for the non-inverting terminal, and for that reasons it is amplified in the output, that is looks like that. You show this is amplified. So what is the meaning of this particular term, that is the non-inverting term, and it is the inverting terminal, it is the inverting input terminal. So I am introducing the signal in here, which is this. Suppose one signal is in here. So for that reasons, again, if I am amplify these things in the output side, I get amplifications, but it change its phase. You saw it's a signal, it's amplify, but things is that it's inverting, invertly amplify. What happened? Whatever the signal I am giving here, it's amplify, but it is invert. Whatever the signal I am giving here, it's amplify, but it is invert. Whatever the signal I am giving in here, it's in amplify only. Okay, whatever the signal I am giving here, this is in the non-inverting terminal, it's just amplify. Here I am introducing the signal in the inverting terminal, it is amplify but invertly amplified. So for that reasons we can say that is inverting input, and here it is called the non-inverting input. This is the non-inverting input, this is the inverting input and non-inverting input. Okay, so for that reasons of this, the resultant is this. For the reason of this, resultant is this. Okay, now a very interesting question. The question is to you that find out these things in your mind, that Suppose I am introducing the same signal in here and here. Same signal at the same time, at the same conditions. I am introducing the signal in here and here, at the same signal in here and here. So at the same time, this particular, for the purpose of this effect is there, and for the purpose of this output effect is like that. So for that purpose, this and this are resultantly give the output. I again repeat these things, my dear students, that for this particular signal, this signal which is amplified, for this signal it is invertingly amplified. Okay. Now at the same time I am introducing the signal here and here at the same time. So for that reasons, what happened? It is amplified, and for the reasons of this it is amplified, representing like that, and for the reasons of this it is representing like that at the same time. At the same time, that means both are resultant. When it is amplified, it's give, and at that time it's another amplifications is looks like that. So for that reason, this part is neutralized by this, and this part is neutralized by this, and for that point of view the output result is tends to 0. Output is tends to 0, and you show there is some operations is happened. What happened? This part is neutralized by this part is neutralized by this, and it tends to 0. Its output is tends to 0. So for that point of view, we can represent that operational amplifier is operating comparatively. And one thing, suppose it is in your mind, so sir, if I am introducing the signal in here like that way, then what happened? Suppose here one signal is representing, and here one inverted signals is representing. Same inverting signal is I am representing in here. So for that reasons, what will be the output? For that reasons, the output is looks like, for that reasons the output is looks like that. For that reasons the output is looks like that, and for that reasons the output is looks like this. For this output is looks like, because this is also inverting, as it is the inverting input terminal, it is the non-inverting. So the resultant of this both, is representing like that way. The resultant of this particular both is representing like that way. That is a huge amplifications in the output side, and give a resultant of this and this, and get a huge amplifications of the output side, and it's operate like that way. So for that point of view, it's the comparative operations which is done by this operational amplifier. We can say that operational amplifier act as an amplifier, and it's also operate these things. Now the factor is that it is in your mind that these things is happened inside of these things, how it is happened, why these things is working like that way. That's the several part. I will come to this matter, but before that we want to represent that these things, there is the operational amplifier in your books or in your study from internet or whatever portions. Some of the there you show there is another two lead, where it is say that VCC minus VCC. It not necessary to give this plus VCC minus VCC, but some of the books, some of the internet resource, they can use this particular plus VCC and minus VCC terms. Basically, actually this is the supply voltage, plus VCC and minus VCC. In case of operational IC, there is a two supply voltage. One is the plus VCC supply, another is the minus VCC supply. Suppose plus 10 volt and minus 10 volt. Okay, so like that way, plus VCC and minus VCC is introduced in here. Plus VCC supply and minus VCC supply is introducing in here. Now the fact is that you can able to draw the operational amplifier like that, or you can omit this part, that not mandatory necessary to give this particular part, but things is that this is there for understand. But what is the reason behind this plus VCC and minus VCC? I want to say that for amplification purpose of the positive part, for the amplifications part purpose of the positive part of the voltage, this plus VCC voltage is working for that. For the purpose of amplification, the positive part of the signal, this plus VCC is working, and for the purpose of the negative part of the amplifications, this negative minus VCC is working. So for these two voltage are vital in case of operational amplifier. So by this way, today we in this module we can understand the operational amplifier symbolic representation and inverting in non-inverting concept, and this plus VCC minus VCC and output, and how the operational amplifier is act, that things we can understand. For the next video we'll go for the deep of the operational amplifier. Thank you very much. Hi. In case of operational amplifier, in the previous some video we can understand about its introductions, and we know about the symbolic representations of the operational amplifier. Now today's module we want to know about the deeply inside of the operational amplifier concept. That things is that first of all I want to draw one home. Okay, it's a very simple home. I am not very good drawing master. Suppose this is a home. Okay, suppose it is two-star home. There is a railing. Okay, so in this home, if I am asking you this question, that what is the main basic unit of this home? Unit. I think you strange about that. Sir, what you say, that unit of the home, unit of your house. Yes, my dear students, that unit means not like that way. We are not explaining like that way. I am representing that unit means from which, what are the unit things by this home is developed. There is a first basic unit is the bricks. In civil engineer concept, that bricks is the best. Also there is sand, there is cement, okay, and railing. You show there is railing, rod, there is rod, railing. So different parts, by using the part, this particular building is developed. Like that way, if you consider the IC, any kinds of IC, inside of this IC, it's built by the electronics material, and the basic unit of the ICs are, at the first traditional mode, it is the transistor, and the other things is the MOS, CMOS, metal oxide semiconductor, complementary metal oxide semiconductor, and transistor. So we have know about that the basic unit of the operational amplifier is the transistor, or basic unit of the operational amplifier is the MOS or CMOS, because using the MOS and CMOS, inside of the operational amplifier is constructed. So this is the basic of the operational amplifier, where the IC is op-amp. Inside op-amp, what are the things are there? That is basically the transistor and the MOS and CMOS. Now go for the next step, that the operational amplifier, how it is inside of the operational amplifier, how it is step by step working, that things. So for that reasons, first of all I want to study about that whatever the things is there inside of the operational amplifier, how it is working in the operational amplifier, that things is representing step by step, that things is representing one by one step. So these are the step is what are the step is there, these things I am representing here. That the in case of operational amplifier, the first step is that the differential amplifier. What is differential amplifier? Okay, I will come. Next step is that another differential amplifier. So this is called the first differential amplifier and this is called the second differential amplifier. Second differential amplifier. Next one, level shifter and buffer. So I will come to all this point. Okay. Second step is the level shifter and buffer, and then the last step and very important step, that is the output stage. So these are the basic block diagram of the inside of the operational amplifier. That means if you considering this is the op amp, this is plus, this is minus, that means non-inverting and inverting terminal. So inside of this two is inserted in the first differential amplifier, then second differential amplifier, then level shifter, and then buffer, and then output stage. I have already go through the first lecture, second lecture of this operational amplifier. If I am introducing the same signal in here, this output is tends to 0. I think you remind it. So as the first and the second, these two part, if I'm introducing these two and then output is tends to 0. So for that point of view, I want to explain one very important thing by the transistor, then you can understand these things. So there is one circuit and you show, suppose this is a Q1 transistor and this is Q2 transistors, okay, and I say that Q1 and Q2 is identical transistor. Q1 and Q2 is the identical transistor. Identical means these two transistors are same like mirror like same. Whatever the capability of this particular transistor, same capability of this particular transistors. So what happened, if I am considering the voltage from these particular portions, so if I am introducing the voltage V1 and V1, same voltage in here, both the portions, so the amplifications voltage V2 is also same in these positions. I have you know about the amplifications portions of the transistor when we have studied how this particular voltage is coming. These things we have already studied in the transistor portions. So for that point of view, for this V1 and this V2, the same voltage is coming in here and here. The voltage of these Q1 transistors with the ground and voltage of this particular Q2 transistors is also the same voltage. If these two are same voltage, so what will be the if I am introducing this particular part to a multimeter, inside of the multimeter, then what will be the output of the voltage? If I am introducing the voltage, there I am getting the voltage which is equals to 0. We can get the output voltage, that is between these two voltage difference is 0. So for that reasons we are not getting any voltage in the output side. That means I am introducing same voltage and same voltage, we are not getting the output voltage. This is actually the differential amplifier. you show we are introducing the voltage in here and here same voltage, the output voltage is become voltage difference is 0. So I hope you can understand that these are the differential circuit. These two circuit are inside of this first differential amplifier and second differential amplifier, and cascaded of these two. Cascaded of these two. Cascaded of these two means how? Cascade means input both the output is introducing to the input like a cascade mode. Cascade matters. How the circuit is developed, that things we also again develop these things again for the inside of the operational amplifier. Just give me some time. That is so this is actually the input of the operational amplifier. Okay, this is actually the input. Suppose I am considering this is non-inverting input and this is the inverting input terminal of the operational amplifier, and this is this and this two voltage. Okay, and after that I am taking care of this voltage and this voltage, taking this voltage from this particular terminal in here and this particular terminal in here. Okay, and both the terminal is introducing to another differential amplifier. Another differential amplifier. I am introducing the another differential amplifier is here. So one part from here, this difference, and another part from here, here. So there is the output and there is plus VCC. So it is the first differential amplifier and it is the second differential amplifier. So first differential amplifier and second differential amplifier, like that way a circuitry is go through for this operational amplifier. So first differential amplifier, second differential amplifier, level shifter, buffer and output stage. I will come to the second and third. First I want to say that you show there is a transistor. At present now the operational amplifier, inside of the operational amplifier it is developed by the CMOS or MOS, this type of technology, but this is the preliminary mother circuit of the inside of the operational amplifier, and it is a complicated, huge complicated circuit of the operational amplifier, inside of the operational amplifier. So after this two differential amplifier we will go for the level shifter and buffer. So what is the actual work of the differential amplifier in the op-amp, inside of the op-amp, that things you can understand. This is first differential amplifier, second differential amplifier, cascadedly. Then level shifter. Level shifter means the DC level shifting. How the DC level shifting? Suppose there is a AC signal which is like that, and then I want to shifting this DC from these positions to this side and just changing the DC level. That is called the level shifting. That is called the level shifting. We can level shifting from upper side and lower side also. That is the level shifting. And then the buffer. That is requirement purpose, the level shifting and the buffer. Buffer means it's taking some time. Buffer means requirement of a connection. That is it takes some time. Suppose buffer, I think it's a term of the chemistry. You know that buffer, that is it is not alkaline and not acid. In between that there is a buffer, but things in the electronics, the buffer concept is different like that. Buffer means it takes some time. Buffer means it takes some time. Suppose there is a box and this AC signal is introducing in here, and it's again give the output same AC signal, but it takes some time. Suppose 0.001 millisecond, 0.001 millisecond is, or microsecond or microseconds is taking from this person to this person. So this is the buffering for one very small amount of time. It takes some time, and also Also it's matching between this output and input side, matching between this input and output side. When we can understand about the ideal characteristics, then we can understand very easily what is the actual work of the buffer. The things is that in between these two input and output terminals, the matching between these two, the buffer is very mandatory, and this level shifter and then the buffer and then the output stage, it is also very important. The output stage is working for the purpose of this particular output is feeded, how much this output of the operational amplifier feeded to the productive outcome, how much of the output can be capable to utilize, that thing is depending upon the output stage. The output stage is working for the purpose of neutralize the output impedance. Output stage is working for the neutralize, to minimize the output stage as per the activity of the operational amplifier. Okay, so these are the several part of the operational amplifier: differential amplifier, first, second differential amplifier, level shifter and buffer, and then the output stage. Through that way we can go through with that and then proceed for the next step of the operational amplifier, like that way. So these are the step of the operational amplifier. Thank you very much.